Hi everyone, welcome to lesson 1 of our exponents and logs unit. Today's lesson we're going to be talking about characteristics of exponential functions. So the first thing we're going to talk about is exponential function. What is it? So it's basically in this general form of f of x equals c of x, where c is your base value. That base value can be anywhere between 0 and 1, not including 0 and 1, so I'm looking for a fraction usually here, or a decimal, or it could be a c value greater than 1. So any number, and of course c can be any number that's greater than 1. Um, X is always going to be your exponent, and x can be any exponent. It's an element of the real, meaning that it could be a decimal, a fraction, a negative, a positive. So we're going to take a look at this table below here. It says using a table of values, sketch the exponential functions and identify the characteristics below. So if I was given this function here, y equals 2 of x, I want to figure out some of these x values or these y values with the corresponding x values and then graph them. So the very first one here that I'm going to start off with is 0. So basically it's saying anything, so I got 2 exponent 0, of course anything exponent 0 is always going to be equal to 1. 2 exponent 1 will always be 2, and of course 2 squared is 4. So these first three here, not too tough to do. This one here though, if you have 2 exponent negative 1, you can never have a negative exponent, so what you had to do is reciprocate, then you'd end up with 1 over 2. If you had 2 exponent negative 2 again, you can't ever have a negative, so you'd have to reciprocate, so that's 1 over 2 squared, which is now 1 over 4, so that's a quarter. On our graph, we're going to just try our best to graph as many of these coordinates as possible. So my first one is going to be at 0, 1, 1, 2, and at 2, I'm at 4. These other ones here, I'm going to try my best. So I got half and a quarter, so I'm just right above that x-axis. I'm going to now connect my dots, so I'm going to have a line right above the x-axis there as best as I can. And then it's going to get to my dots and connect, and it's just going to go up. So it should curve up. Arrowheads on each end, meaning that it's going to go on forever. Let's talk about the domain on this graph here. The domain as far left as we can go is negative infinity. As far right, well, that arrow is going to go up, and up to the right there it's going to be positive infinity. So my domain is from negative infinity to positive infinity. My range, the lowest I'm going to go is right on this x-axis. I'm never going to truly touch it. I'm going to go get as close as I can there. I'm not going to touch it though, so that's a horizontal asymptote, by the way. So our range, the lowest that we can go was from 0 going all the way up to positive infinity. For our x-intercept, because we didn't cross our x-axis, we're going to have no or none here for x-intercepts. For y-intercepts, we did cross on our y-axis. It's at 0, 1. Our graph was increasing, reading it left to right. And the equation of the horizontal asymptote, again, which line are we trying to skip? The horizontal asymptote is going to be at y equals 0, and that's our horizontal asymptote that I'm trying to skip on this one. If it helps, I'm going to draw in a dotted line right through that axis. And there we have it, right there. Kind of thin, but that's where it's going to go. We're going to go to the next graph here and start this one off. Let's see what we get. So for this graph here, we have a fraction 1 over 2 exponent x. Well, of course, I'm going to start off with 0, so 1 over 2 exponent 0, of course, is going to be 1. 1 half exponent 1 is still going to be 1 half, and 1 half all squared, so that's 1 times 1, and in my numerator, and 2 times 2 in my denominator, so that's going to be 1 quarter. 1 half to the negative 1, so what I have to do is reciprocate or just flip that fraction, and I get 2 over 1, which is now just 2. Here, if it's 1 half to the negative 2, it's going to be, again, reciprocated, so it's going to be 2 over 1 all squared, so now this is going to be positive 4. So on this graph here, I'm going to try to find at negative 2, positive 4, put a coordinate dot right there, At negative 1, I'm at 2. At 0, I was at 1. 1, I was at a half. And 2, I was at a quarter. So again, we're just going to curve away. So that means we have another horizontal asymptote right at 0. And again, I'm going to put in a dotted line, hoping that you can see it, and it's going to curve away from there. I'm just going to add in 3, negative 8 to help me guide my coordinates here. And again, I'm just going to slowly connect my dots here as best as I can, and trying to really avoid that x axis there, really, but try to get as close as we can, and that's sufficient enough. And there we go, arrowheads on each end. The domain on this graph here, again, as far left as we're going, is to negative infinity, and as far right is positive infinity. So from negative infinity to positive infinity, there we go. Our range, the lowest we're going to go is 0, and the highest we're going to go is positive infinity. Because of this end here, we're going upwards. Our x-intercept, we don't cross our x-axis, so we're going to have no or none x-intercepts. Y-intercept, we crossed at 0, 1. And in this case here, reading our graph left to right, we are decreasing. And our equation for our horizontal asymptote is going to be at y equals 0. Moving down here, it says based on the previous examples, for the values of c, an exponential function is increasing if, well, we're only increasing if our c value was greater than 1. We're decreasing if our c values anywhere between 0 and 1. It can't be 1 and it can't be 0, because you can't graph anything with a base 0 or a base 1. Base 1 would just be a straight line. Which down here says what graphical characteristics are common to all exponential functions regardless of the value of the base. So basically it's asking you, out of these characteristics up here, which one's the same, or if you really want, which one's the only one that's different. Well, the only one that's different is our direction, our increasing or decreasing. So all characteristics are the same. So all characteristics the same except for really, it's except for the direction, if it's increasing or decreasing. Increase slash decrease. So I and C is increase, D is decrease. In example 2, we're given the function this time. We're actually given the graph, and we're asked to figure out the function. We're asked to figure out the graph. So what you want to do is look through this graph here and find any coordinates that you can read. I'm just going to slightly zoom in here and see if we can get a better picture of some of the coordinates here. Let me try that again. There we go. So on this first graph here, I'm going to take a look at my graph and pick out points that I can read cleanly. I can definitely read that coordinate there. That's 0, 1. That's my y-intercept. The next coordinate I can see cleanly is right here, and that looks to be negative 1, positive 4. Over here, there's nothing else, and to the left of this, there's nothing else. So really, I only have two coordinates that I can read. Well, first off, I need to ask myself, is my graph increasing going left to right, or is it decreasing going left to right? Going left to right, my graph is decreasing. Therefore, my c value has to be between 0 and 1. So I'm looking for a fraction, definitely for a c value. The way that we're going to do this is we're going to fill in our equation, and our equation is y equals c exponent x. Well, if you choose 0, 1 and you chose 0, 1 in here, well, this is c exponent 0 equals 1. That really doesn't help us because anything exponent 0 is always going to be 1. So let's choose this other coordinate to try to help us figure this out. So let's sub that in. So if you had y of 4 equals c of exponent 1 for x, or negative 1 for x, well, this here I need to reciprocate because I can't have a negative exponent. So this is now 4 equals 1 over c. Well, let's isolate for c. So I'm going to multiply both sides by c, and let's see what we get. Multiply both sides by c. This c and c will cancel. I'm left with 4c over here. So right now I have 4c equals 1, and of course I want to isolate for c, so I'm going to divide both sides by 4, so now I have 1/4. And again, double checking, does it fit this condition of between 0 and 1? Yes, it does. So most likely, therefore, our final equation is y equals 1/4 exponent x. And if you want, this quarter could be in brackets, and then that means that x is to both numerator and denominator. In this next graph here, we're going to take a look again. Let's find coordinates that we can read cleanly. So here on this graph here, I have the y-intercept that's at 0, 1, and the next one I have is right here at 1, 3. I don't have any other coordinates, so I'm just going to use what I'm given. Well, I'm actually given 2, potentially 2, 9, but 1, 3 will suffice. Again, what I want to do is sub it into my equation. So I have y equals c of x as my base equation. Subbing in 3 and 1, what do we get? We get 3 equals c to the exponent 1. Well, c exponent 1 is just c. So therefore, c has to equal 3. So my final equation will be y equals 3 exponent x. And that's how we develop this equation here. So again, always look for a coordinate that you can read, and then all you have to do is sub in your xy and isolate for c. The last question for today is saying, and let me try to zoom out here, is saying that we usually use exponential functions to model real life situations, so basically word problems. So we're talking about bacteria growth, radioactive decay, population. Other ones that we've talked about are pH values or decibels and hertz, and so it's all real life situations that we're modeling. Here's your base equation that we usually use: y equals a c of x, where a is always your initial amount, c is your growth or decay factor, and x is your amount of time. So for this last question here, last two questions, the first one here, we want to develop our equation and then determine the question here. So to develop this equation, so we have a number of bacteria in a petri dish is increasing at a rate of 90% per hour. Assume the petri dish started with one bacterium. So things that I know, y is what I always start off with. Y equals. I know that I'm starting off with one bacterium, so my a value has to be 1. So that's going to be my starting value. Here, my factor, most students will write down 90%. Well, you can never have a percentage in your question. Okay, percentages don't actually work here, so you'd have to convert it. So then most students will then try to convert it to 0.9. But again, if we are increasing, if you only have 0.9, that means you're decreasing. You're losing you're losing a 10% or 0.1 every time. So what you really want to do is, if you're ever increasing, take this percentage and add it to 1. So now you have a rate of 1.9. So now this means that you're increasing at 90%. This one just means that you have 100%, or you started whole at 100%, and you're going to increase 90% from there. Down here it says graph the function and determine how long it will take for the population to reach 1,000. So if I know I'm trying to reach 1,000, I'm going to have y equals 1,000 equals 1 times 1.9 all to the exponent x, and that's going to be my equation. What I want to do is graph y1, y2. So this one here I'll graph as y1, and all of this over here I'll graph as y2, and I'm looking for my x value, so looking for x. And so that's what I'm looking for on my graphing calculator. So here we go. Let's go into y equals. Make sure that everything is nice and cleared off. I'm going to type in 1,000 into y1 there, and 1 multiplied by 1.9 exponent x there, in Y2. I want to change my window setting because I'm going as high as at least 1,000. So I'm going to change these here to back to a standard window of -10. Let's go -10, 10, and 1. In fact, I'm just going to bump it out a bit more. Let's go 15, 15, and 1. And my Y values, I definitely want to go higher than 10 because I'm going to at least 1,000 minimum. Let's go higher. So let's go something like you can even go 2,000 if you want to. But again, if you're changing your Y max, you want to change your scale to something reasonable. You probably don't want to go by tens, go by hundreds. Let's see what we get. So there's my line and there's my second line, and they clearly intersect. So I'm going to go second, trace option 5, and moving my cursor as far right as I can to where they cross, hit enter 3 times there, and that's going to be my answer. So I have an answer of 10.76 as an answer, and of course it doesn't tell you how much to round to, so let's just go either, write down our answer of either. So how long will it take? X equals 10.76, and that's in terms of hours. So I'd have hours there, or you can have 10.8 hours. Both would have been perfectly fine. There's no decimal asked for in this question. In the last example, today we have the amount of fish in a lake is decreasing by 12% each year. Write an exponential function to model this. So again, we're filling in our equation. So we got y equals, in this case here, you want to start off with 1. It doesn't tell you how many fish you have in the lake, but you're going to assume 1 or 100% of fish were there. You're decreasing by 12% each year, so really you're going to go 1 minus 0.12 because you're going to decrease by 12% each year. So what percentage is left over to the exponent x there? Let's clean up this equation really quickly. This is now y equals 1 multiplied by 0.88. And again, that 1 can probably disappear because it's just 1. So this is what I'm trying to solve, 0.88x. What percentage of fish would be left after 6 years? So let's fill in our equation. 0.88, and of course x will be 6 because that's going to be 6 years there. And so we have y equals, so on my calculator here, 0.88 exponent 6. There we go. So we got 0.4644. So 0.4644. And of course, this is a decimal. We're asking you for a percentage. So just convert that over to a percent. So that's about 46%. And that's the end of lesson 1. If you have any questions, please feel free to ask.